we're going to be looking at this problem in which you have this satellite and it's traveling in the x direction, and then again it's going to turn its thruster on, which are these flames right here. It's not on fire, it's just turning its thruster on, and it's going to turn 90 degrees. The first step of any problem is to set your coordinates. So we're going to say that x is going in this direction and y is going up. Alright. Then let's make our equations. So we have our equation on f direction. F of x times t is equal to, and then just a quick note, so final and initial, I'm going to be using final position is f, and then initial position is I. So you can imagine that that's basically the path it's taking. It starts from here, ends over there. And so this is going to be mf final minus mf initial. And you're always going to take final minus initial. Then in the y direction, fyt is equal to mvfy minus mviy. Now a quick note, looking at this initial and final positioning, you can see that at first there is no velocity going in the y direction. And so you can actually cross out this, so that's 0, because it's not traveling at all in the y direction. And at the end, it's made a complete 90-degree turn. So there's no x direction velocity. And so your final x direction velocity is also going to be 0. Now we're going to substitute in our f of t and make our f of t equal to some form of f of x and f of y. F of x, so quick note, if you can make a triangle, and you can imagine that this is ft, this is fy, and fx, using SOHCAHTOA, we can see that the opposite to the 30-degree angle is f of y, and so this is going to be sine. And next to, or adjacent to the angle is our f of x, and that's going to be our cosine. So now f of x is equal to ft times cosine of 30 degrees. And our fy is equal to ft sine of 30 degrees. Okay? And we're going to substitute that back into our equations. And we're going to see that ft cosine of 30, plugging this back into there, is equal to, times time is equal to negative mass times velocity initial in the x direction. Let me just move that over there. Boop. Then in our y direction, I'm going to substitute this into there. ft sine 30 times time is equal to mv final y. Now we can just basically plug in all of our numbers and solve for this. So in the x direction, we have ft, which is 600 times cosine 30 times the time is equal to negative 12 times our initial velocity, 600, and we find that time is equal to 13.86 seconds. Then we're going to use that in our y direction, and we're going to see that 600 sine 30 times that time that we're plugging in that we got from the x equation, 13.86, is equal to the mass is 12,000 times our final velocity in the y direction. And once we solve that, you'll find that vfy is equal to negative 346, I believe, 0.4 meters per second. And that's how you solve this problem.